Hi. In the last video I worked on a top-down design of the reset circuit. I got all that built out in KiCad and then turned around and implemented that in the emulator. Today I want to take that same circuit and actually put it on breadboard, and I want to compare how my emulator works to what's going to happen in real life on the breadboard. I also have a long laundry list of things that I do need to button up and clean up, and I've got those all listed out in GitHub. And there's a link in the description if you want to follow along with that as well. At the end of the day, the goal is to have a working reset circuit on breadboard, and then a number of these issues also tied up and behind me. All right, let's get into that.
Hi, I'm Adam. I'm still building a 16-bit computer from scratch. I'm no expert here. I make lots of mistakes. So many mistakes I've actually had to reboot my computer build. I hope you will find my journey interesting, and I hope you will join me as I learn along the way.
My wife Carrie has been working on a cookbook. Carrie's cookbook provides a unique culinary experience by seamlessly incorporating doTERRA essential oils into a diverse array of mouth-watering recipes, transforming ordinary meals into extraordinary dining adventures. The cookbook offers a treasure trove of innovative dishes that combine the health benefits and aromatic richness of essential oils with fresh, wholesome ingredients, making gourmet cooking accessible and exciting for everyone from novice home cooks to seasoned chefs. Each thoughtfully crafted recipe not only tantalizes the taste buds, but also promotes an overall well-being, harnessing the natural potency of pure essential oils such as lavender, lemon, peppermint, and basil. In Carrie's cookbook, she emphasizes the quality, flavor, and simplicity, guiding you through detailed, easy-to-follow instructions with beautiful photography and expert tips. Whether you're looking to elevate your everyday meals, explore new flavor horizons, or embrace a healthier lifestyle, Carrie's Cookbook is your ultimate guide to enriching your kitchen and your life with the magic of doTERRA essential oils. If you are interested, there's a link in the description. Okay, here's the schematic I put together in the last video. Now this particular sheet has a few passives on it, some unused gates and the like that need to be tied, and I will work on getting those done. This has the actual voltage supervisor that is wired in order to trigger the reset signal. And that is this here, which I've pulled off the existing clock circuit. I'll have to kind of shore that up a little bit before I can actually run a test. Interestingly enough, this was the first thing I put together for this video series. This was the topic of video 1. I'll put a link in the description. This is the reset switch, which also will present the reset signal, and that will be this button here. Then I've got some combinational logic here. Now I've got an AND gate, an OR gate, and then a NAND gate and a NOR gate on here. I only have one AND IC, I only have one OR IC, I only have one NOR IC, but I have several of these NAND ICs on here. This is the AND gate, this is the OR gate. The NOR gate is all the way up here in my layout. And then I can go to any one of these three NAND ICs and call that NAND gate 1. Let me bookmark that for a second and come back to it. This is the counter, which then cycles the clock a certain number of times after everything is copied over to clear out the fetch and the instruction registers, make sure everything's actually cleared. And these set reset latch here is NAND gate 2, but here's the 74HC193. Now that's a 74HC193. Here is a NAND gate here, and here's the latch. The latch is one of these. Now it would make sense that this would be NAND gate 2 here. But if I look at this, I've got NAND gate 1, and it would be also very good to use this to drag the signal from the NOR gate up here through this NAND gate here and then down into the AND gate. It's just a simple matter of updating the schematic, but I think in the PCB, the routing is going to be better for that as well. This is the tri-condition latch with the 74HC123. These signals go through NAND gates, and then I've got 6 other NAND gates that are used with some NOR gates and then an open drain NAND gate here to drive the reset hold. Well, that's all up here lined up, but again, if I can keep all 8 of those NAND gates to be these two, that's going to actually work out better for wiring this up. I have NAND gate 1, NAND gate 2, and NAND gate 3 here. So it makes some sense to reorganize this a little bit and just change which gates are actually being used. And then I have also LS logic mixed with HC logic. Now I could put pull-up resistors on the outputs, but I'm thinking I might want to try driving this through an NPN transistor and just see how that works. The LS cannot drive the HC logic directly. It does need some assistance. Let me circle back to the schematic and update the names of which IC is which and update the signal names. And then I will place these in and start with power, ground, and decoupling in some of the passives. I'll start the cleanup by exchanging NAND 1 and NAND 2 on the schematic. I only need to worry about gates 3 and 4 on each of those ICs, and they align nicely. And then I'll update the emulator to match. Now, of course, this is going to need a test, and so I will run through and make sure that everything actually works properly. Nice. It was recommended to me some time back that I try soldering the capacitors to the individual ICs, and I haven't dared to try that until now. My goal is to get this set underneath so that I can actually push the capacitor into the trench here, set the IC on top of it, and kind of get that out of the way. And so to do that, I need to solder to this pin down here and then solder to this pin up here. Let's see how that goes. This could be interesting. I'm going to try a little bit better flux here. Of course, now I've got flux running down into my into my breadboard. Okay, so then I should be able to trim off the excess here. And now I should be able to drop this right in here and have my decoupling for that IC tucked out of the way. Nice, I think that's going to work. Actually, I like having the decoupling caps underneath the ICs. It allows me to see what each IC is far more clearly. Next up, I work on power and ground. Now there's a lot of connections here to make sure that all the different power rails are connected. Now I know it doesn't show up on camera, but I've made an effort to make these connections as neat as possible. Not sure I did a good job. Next is ground for each of the ICs. Now for VCC for each IC. And last but not least are the bulk decoupling caps. Next, I want to tie all of these unused gates. The 74HC03 has 3 unused gates. That's gate 2, gate 3, and gate 4. So gate 2, 3, and 4, I'm all going to tie low. Now in this case, I have to work around the capacitors. OR gates 3 and 4 are unused, and gates 3 and 4 are unused. Now here it's 3, 4, 3, 4, and with the signals coming from the top part of the breadboard, it would be better for 1 and 2 to be unused, 3 and 4 to actually carry those signals. Let me do a quick change on that. Okay, the changes made the emulator test okay. My latch has all the inputs tied low. Okay, the last thing I will tackle on this page right now is hooking up this OR gate for the diode. I want to use the OR gate to drive it. I only need one diode, so I don't necessarily need a specific driver for it. But I want to get this hooked up so that it is ready to go. I moved this to be OR gate 3 on that IC. Next is the voltage supervisor. All right, manual reset next. At the same time, I will install its 10,000 ohm pull-up resistor. Okay, I want to create this interface point on the breadboard so that all the signals come in to a single location. To facilitate that, I created this label that will help me keep track of exactly what signal goes where. This combinational logic determines the clock. Okay, so this segment was a huge pain to complete. It actually took me 4 attempts. Obviously, I'm not making the wires and bending them to put into place right on the video. I'm doing that ahead of time. But in this case, there were so many wires that were pre-bent that I struggled to actually keep them all straight and get them all inserted in the right sequence. Got to come up with a better method here. Now I know I said I was going to use a transistor to shape this signal, but for the transistor I would need a pull down resistor in order to make that work, and so why add extra complexity? So for the output of that NOR gate, which is driving an input here on an HC, LS logic, HC logic, I'm adding a 10,000 ohm pull-up resistor there to try to pull that signal high so that the HC logic will work 100% of the time. Okay, next on the list is the subcircuit to clock the entire CPU a number of times after the reset copy is completed. I'll start here with the switches. This is going to determine how many clock cycles I actually have to clock in order to clear the CPU. Next is the D-type latch. Okay, next I will take care of the set reset latch here. Finally, the counter IC. The final subcircuit to look at here is the three-state latch. Now there's a lot going on this page, so I need to break this down into smaller components here. I'm going to start over here with 74HC123. Now I've got a 74LS123, so I'm going to have to work with the outputs of that to make sure that they can make it all the way up to the high levels that the HC logic is expecting. But I want to start with these passive components here to make sure that I get the right timing of that clock pulse that I need in order to execute these resets. Let's go to the datasheet first. Okay, this is the datasheet for a 74HC123 and a 74HCT123. I've looked up the formulas for 74LS123 and they're very similar, with the only difference here being the actual constant for the calculation. So the calculation is the pulse width time in microseconds is some constant times the resistance in kiloohms times the capacitance in picofarad. And as a matter of fact, for both the HCT as well as the HC, they've done a couple of sample calculations for me. And I'm interested in this one here, where the capacitance is 100 nanofarads, or 0.1 microfarads, and the resistance is 10,000 K. The pulse width time becomes 450 microseconds, or rounding up, let's call it about half of a millisecond, maybe a little less. The formulas for the LS logic are very similar. The constant is 0.37 instead of 0.45. So we end up with 370 microseconds, or just over a third of a millisecond. That's close enough to get me through this test on Breadboard. So now I have the capacitance value I'm looking for and the resistance value I'm looking for. Okay, so as placeholders, I had put in a 0.1 microfarad or 100 nanofarad capacitor, put in a 100 ohm resistor, and I need to swap that out for a 10K ohm resistor. And so I will make that update in the schematic really quick, and then I will start plugging these passives into the breadboard. Alright, the next thing I want to tackle on the subcircuit is all of these set reset latches on the NAND gates and get those wired up. Okay, the inputs for the open drain NAND gate I'm using as an inverter. Okay, the inputs into these NAND gates. Remember, I'm going from an LS to an HC, so these two signals here are going to require pull-up resistor. Two inputs into this NOR gate. Now the HC logic can drive an LS high. The inputs for this NOR gate. Finally, this NOR gate. The inputs into this set reset latch. Inputs for this set reset latch. The inputs for the final set reset latch. Okay, the final thing for the breadboard is extending these four outputs. Okay, this is the point in time where I get to find out if I read the datasheet for the 74LS 74HC 123 and understood exactly how that works, and if this reset circuit is going to work on breadboard the way it does in the emulator. Now, I've never used a 74 123 before. I may or may not have understood the datasheet. I certainly forced the emulator to work the way that I thought it should, but reality may be different. All right, down in the comments, place your bets. Is this going to work first time, or am I going to spend the rest of the video debugging? I certainly still have a list of things to get to that I'm hoping to get to in this video. This is the point in time I'm going to find out if the video is going to have enough time left for those. Place your bets. All right, Adam. So what have you done? Well, I did pull my voltage supervisor out of my clock circuit and moved it over here. I also pulled out the reset button itself, and that signal also had a pull-up resistor over here, so I removed the pull-up resistor so that I didn't end up having two of those and then getting half the resistance. My reset signal, which is now coming off of this button, is now an output to the same reset signal over here, so that one button now drives them both. My high-speed system clock is connected to my system clock. My CPU clock is connected to the CPU clock. Of course, I've got power and ground. And then I took three of my four outputs, resetting, CPU clocking, and then running, and connected them up to the first three LEDs over here. I've got those tied to ground. And the last connection I made was the copy hold signal. Now this is low while it's copying. I do not have the control ROM midplane hooked up. I am going to need to manually simulate that signal, so when I am done copying, I'll just disconnect that signal. There's a pull-up resistor that will pull that high. All right, did you log your bets below? Let's give it a shot. Well, that's not good. I see that I am in copying and I am in running mode. This LED here on the right is not hooked up at all. I'm still in reset, which is incongruent with that LED there. If I pull that out, it doesn't change any states. So do I have a voltage problem? Do I have a wiring problem? Do I have an issue with my understanding of the 74 123? Raise your hand if you got that right. Let me get some test equipment out. I'm going to start with some basic measurements here. And the first of which is going to be VCC. And I should be able to pick that up here. Well, that's certainly a problem. I don't have VCC. I never connected this one to positive power. Well, let's start with that. Okay, let's give this a shot. Okay, let's go back and test voltage like I was planning to in the beginning. Okay, that's 5 volts. Got a good 5 volts there. So my reset signal should be high, which is correct. Reset, that should pull low, which it does. Okay, so reset is working correctly. There's something going on here. That's the output. There's the input. I do not have a pull-up resistor on this signal. So my copy hold is not actually coming high, so let's make it high. I did not set that value, so let's set that. Try a reset again. So I'm counting properly. So that would have triggered. So my output doesn't go anywhere. This would be my output of my set reset. Okay, this requires a schematic. My input to pin 13 is borrow out. My input to pin 9, that is correct. That's copy hold. Now the output here coming off of pin 6, 2, 3, 4, 5, 6. This is not going anywhere, and it should. Where does run need to go? So my output here, which is on pin 6, is supposed to be an input into pin 10 up here. Let's see here. We've got, should be going there. Let's see if I can't patch that up relatively quickly. So pin 6 should be going to pin 10. Better power connections. Okay, that should still be in reset, and it's not. It should be the input. It should be pin 2, which does not have an input. So copy hold should also go there. Okay, after about another half hour of troubleshooting, I realized that I am not actually getting a pulse out of the 74 LS123 IC that's on the breadboard. So it's time to figure out how this thing really works, and then of course update the emulator to match that so that I can get this circuit on breadboard to work properly. So I've got a 74 LS123 here in a breadboard, and I'm going to simply duplicate this circuit right here. The goal here is to take this as a starting point and then figure out what I need to change in order to make this work. Now I'll just be measuring the output here on Q, and I will hook up an LED in its place. Okay, I think that's wired up correctly. 1 goes to ground. 2 is my signal, which when I push the button pulls it high. 3 is to ground. 4 is unused. 13 is my pulse here. 14 is my capacitor. 15 is my resistor to VCC. Okay, I may have to adjust either of these in order to make sure that I get the length that I need. It may not light the LED, but let's give this a shot here. And that is not doing anything like what I wanted it to do. So let's pull this out. 47 microfarad. Let's hope I'm putting this in oriented properly. That does nothing. Let's go with a bigger resistor. Okay, I'm going to swap a 10,000 ohm resistor for a 100,000 ohm resistor. That should give me 10 times the width of the pulse. And that's basically the same behavior I'm getting on the breadboard. So now I got to figure this out. What do I need to do in order to get this to work? Okay, for the sake of the video, I'm going to replace this 100,000 ohm resistor with a 470,000 ohm resistor. And the whole point of that is to try to get the LED to remain on long enough that the video actually picks it up. So when I push the button, it simulates the copy hold signal going low, as in I'm copying. When I release, the LED does turn on. Now I have not debounced this particular button, but when I release it, you can see that the light actually does pulse. That is the intended behavior here. Now, what did I change? Well, I will bring up the truth table, but ultimately it's pin 3 that changed. It needs to go to VCC, and I had it at ground. So looking at the functional description here, the way I had it wired was RD was low, which means it didn't matter what the other two inputs were. I have since changed that to be high with the A input low and set it up so that B is now on the rising edge, that it now creates that pulse. Not exactly sure how I misread that. I don't know how I did that. I should not have done that. So let me make these changes on the breadboard and we'll give that a test again, figure out what is wrong now next. The two signals that now need to change are on pin 3 and pin 11. So in the middle of all of this mess, pin 3 is one and pin 11 is the other. All right, let's try this and see what happens. Okay, I do still have an issue here. There is still something going on here that I do need to sort out. It's not coming out of reset. So let me get back into tracing here. After some playing, let me show you what I've got here. If I bring this into copy hold and I hit a reset, and then when I bring this out of copy hold, it does advance that signal properly. And it does actually turn off. Now, I am expecting this LED here to come on, which it did. How that's happening, I don't know. This LED should turn off at the same time this one turns on, and it is not. So there's still something going on here. So it does require that transition, which is fine. So I'm in reset, copy is complete, and then it goes off. But this LED is supposed to be on, it's on when it's supposed to be off. So this one has an inversion problem, it looks like. There it is, now it's finally back on again. I am missing an input here into this OR gate, so it's not being driven properly. That should be the output off of the HC03. Now I probably need a pull up resistor to get that to work right. This is completely backwards, and this is completely backwards. But other than that, the circuit is actually behaving better. All right, so that said, I have some changes to make to the schematic for this, for pin 3 and pin 11. Let me get on to that, and then I will make those same changes in the emulator and get that working again quickly. Test number 1 didn't work. Test number 2 didn't work. Perfect. Okay, the last issue here is my running signal is actually coming off of the input into the open drain NAND gate, which is being actually driven from pin 11 here. Well, that's incorrect. So this signal really should be driven from pin 8 here on the NAND gate. So let me try this. And I'm just going to drag it up here for the moment. Push and hold reset. Move this signal low so that it indicates that I'm copying. Release. Once I'm done copying, I move this signal from low to high. It advances. And then after the right number of clock ticks, I'm now in running mode. The challenge here is this LED is congruent with that LED, and it should not be. Well, it's being driven by the correct signal. I just have it backwards. So let's flip this so that sync current instead of source current. And let's try that again. Push and hold reset. Go into copy hold. Release. I'm done copying. And now I'm in running mode. So this indicates that I'm now out of reset. That is working as I expect. Now I've got some cleanup I need to do here. I need to roll up my sleeves and get into that. Okay, let's start with cleaning up the LED on the schematic. I'm going to start by cleaning up reset, hold. Now this has a pull-up resistor that's here. I want to relocate that down here underneath my label to get it out of the way. And then this signal should be able to terminate right here. And then I should be able to pick up that signal and carry it over here. So let me see what I can do about that and getting it aligned properly. Okay, next order of business is to replace this running signal. Copy hold needs a pull-up resistor. For ease, I'm going to relocate the reset pull-up resistor. Reset, resetting, copying, and running. Perfect. Okay, I've got this all hooked back up again in order to try to give this a good test. Now, the reset is going to trigger the copy of all of the control ROMs. And then when the control ROMs are done, copy hold will be disconnected. And then so the pull-up resistor will bring that signal high, which will trigger all the rest of the copying and the like. So let's give that a shot here. And this is not the pattern that I was expecting to see. And for some reason that is not holding. So resetting, copying, and then running. But that's incorrect. It should remain in resetting as long as it's copying over here. Okay, I spent a good few hours off video working through some of the issues that I found. And let me call out for you specifically what those issues are. Now, I apologize for the background noise. I've got my 3D printer going in the background again. First of all, you will see some new circuitry here. Ignore that for the moment. It is disconnected. I want to work through this without it first, and then I will reconnect that back up, and then we'll talk through what my solutions are. So no matter what I did on a cold start, whether I started the clock or not, at the end of it, not everything actually copied properly. Now, I am expecting, I still have my high EEPROM addresses all ones with every bit turned on. So every one of these blue LEDs is supposed to light up. If I do a warm reset, that works exactly the way that I want it to. And it's pretty consistent. It fails every time on a cold reset. It works every time on a warm reset. So that's issue number one. Issue number two is related to these LEDs. Now, as I do the reset, this LED here on the left is intended to be when I'm resetting. So as soon as I press the reset button, until this copy is complete. The second LED along, still not lit, is supposed to be when the CPU is clocking in order to clear out the fetch register and the instruction register, and those have to happen after I know what my no-op operation is here. So I've got 7 clocks that are defined. After it clocks those 7, it's supposed to move to the LED that's lit, indicating it's in running mode. So when I hit reset, it almost immediately moves to the copy, even though this hasn't completed. Once it's done, it actually, after 7 clock cycles, moves on to the running mode. Eventually, the end state is correct, but this is not technically correct, and I've traced that down to a bodge I need to do on this control ROM control. More on that soon. The third is on power on reset, the clock is not actually starting. And if I don't manually start that, I cannot guarantee that this ends up being in a good known state when I do have this circuit in play. So I'm going to bookmark this and come back to it. This may or may not be something that I can solve today. I do have to redo good portions of this clock circuit, and so I will probably come back and address that at that point as well. So what's all this mess up here? What I figure is, and I haven't proven this yet, but power comes on and almost instantly I'm trying to read the EEPROM and or write to the SRAM when its internal power cycle just hasn't completed yet. And so I'm probably being a little bit too aggressive with trying to pump data from the EEPROM into the SRAM on this reset. So I figure if I'm able to hold the circuit in reset just a little bit longer, I can do it with this capacitor on the 3470, but when I did some testing, it didn't matter how big of a capacitor I put there, there were still issues and it was still inconsistent. So what I thought was, okay, how can I trip this some period of time after the reset is actually complete? And I can do that with an NPN transistor that can actually operate this when the base is on, then it will actually conduct from VCC down to ground, pulling this output signal low. This is an active low signal coming out, and I need this to be an active high signal. So I basically put an inverter in here just to invert, and I just used a transistor, another NPN transistor to do that. But because I've now disconnected the reset for the 3470 from the rest of the circuit, I also need a pull-up resistor here. Now, this 1K resistor is here to limit current going through this transistor when it is on. And this 10K resistor plus this capacitor then provides a delay when this goes low. So when this signal is deasserted, reset is turned off, the pull-up resistor is going to turn this high. This will pull the base high, which will allow this to conduct, which will make this node the same as ground. So here I've got ground. I'm going to drain this capacitor through this 10,000 ohm resistor to ground, holding this node or the base of this transistor high for an extended period of time, allowing that reset to linger for a little bit longer. This is the reset coming off the 3470. This is the system reset, which will be extended out to the rest of the build. So let me put this back in place here. Okay, so now when I turn this on and turn on the clock, it works. Now I'll be honest, it doesn't work 100%, but this is far closer to working than I have had before. And if I need to, I can always just hit the reset and recopy. There's something in this that is not going 100% here, and I'm thinking it might be the breadboard, which is causing me problems. I may have to commit this to PCB and test it on PCB before I can be absolutely certain that that's actually going to work. It was while I was editing my explanation I realized exactly what the problem was and exactly what the solution is. It's very, very simple. The problem is that when this goes low, this is pulled up to VCC, and I'm trying to charge this capacitor through a 10,000 ohm resistor. Well, on cold restart, this capacitor has no voltage, so it actually takes time for it to charge up. Now I can manage that by holding the circuit and reset longer, and that would certainly work. But I thought, what if I put a diode right here across that resistor so that when this came high, it would charge this node quickly, and then when it went low, it would discharge through the resistor. Well, let's give that a shot. I have a small switching diode. It's basically a Schottky diode. I have a whole bag full of them. And one end is going to go here, and the other end is going to go here. Now this has been off for a while and I haven't tried this time. So let's see what happens here. That worked. I'm going to try that about 1,000,000 more times, but I really do believe that I've got that sorted. So if I discharge all of my capacitors, including this one, which is not tied to VCC directly, and I try that again, fail. So I doubled up this capacitor here, so I've got 0.2 microfarad. And so when I actually put this into a design, I'm going to end up making room for several additional capacitors. Just make sure everything's discharged here. But I'll have several capacitors in both places just so that I can tune that a little bit better. That's been consistent now and turned on like 5 times in a row now. So that's good. All right, so cleanup. I've got to clean up the circuit here. I've got to get this into KiCad. And I am not going to move the analog devices into the emulator. I'm going to let that remain as it is. Cleanup time. Okay, it's a new day for me. And throughout the day, I must have power cycled this circuit about 50 times. It worked probably for the first 20 or so, but then it failed once. I've since increased the capacity of that capacitor leading to the 3470 and turned that into a 1 microfarad capacitor, and it's worked ever since. These LEDs are temporary, but these ground connections are in my way. After the simple ground connections, it's on to the passives and semiconductors. I've got a few wires to bend and one to reroute. The orange one here in particular was a little difficult to reroute to its new location. Okay, one final test after the cleanup. Nice. Well, once again, it turns out I was a little ambitious in this video. There's a whole laundry list of things I thought I could have time to get done, and I didn't get to hardly any of them. Ultimately, I probably should have or could have split this into 2 videos. I didn't because I wanted to make sure that I got through a complete thought. If it was going to go much longer, I probably would have bit the bullet and split it up anyway. So the next video will focus on that laundry list of things I didn't get done in this video. Now, should I have time, I am going to start looking at the clock circuit. The clock and the reset are going to make a mid-plane of themselves. I want to start getting prepared to order that and pull that together as well. So this clock circuit does have some changes that I made in this video, and there are more that still are pending. So I do need to take another look at that. Once again, I will be making the code and schematics available on GitHub. There's a link right here, and I will include that in the description as well. Go check it out if you'd like. Thank you for your time. We'll see you soon.